So today I'm going to talk about conditional proposition. And logical equivalence. Okay, let me begin with the definition. So we know what propositions are. So we have two propositions. So conditional proposition is another way to make a proposition out of two propositions. So the proposition if P then Q is called a conditional proposition. And denoted by P if P then Q. If P then Q. This is the notation for this proposition. So in fact, we use this kind of sentence very often in real life. So for instance, so if I have, say, $1,000, then I will buy a laptop. We use this kind of structure in the sentence very often. Right? So this is a conditional proposition. So we need to define. Actually, we have to define when this is true or not, when it's not true. So this is in fact the definition. The truth value of P then Q is defined as follows. So let me define this using truth table. So given the truth values of P and Q, we have to decide whether this is true or not. So there are four possibilities: TT, TF, FT, FF. P is true, Q is true. If P, then Q. Do you think this is true? Yeah, true. Good. What about this? If P is true, then false. False. This is a definition, by the way, but it will be consistent with our intuition. So what about this? True? How many of you think this should be true? Okay. Wait a second. Okay. Yeah. What about this? How many of you think that this is true? This should be true, or in fact, in mathematics definition, there is no requirement for the definition, as long as there is no contradiction. You can define this either true or F, it's your choice, but we want this to be reasonable in the sense that it is kind of the same, analogous to what we use, this kind of sentence. Do you think this is true or false? Let's vote. How many of you think this should be defined to be true? Okay. And how many of you think this should be defined to be false? No one? Okay, let's define this to be true then. So in fact, this is the usual way to define this truth value. This this definition is natural. Natural. In the following sense, in this sense. In this sense. Let me give you a statement like this. Example. If you do your homework, then you will get an A for this course. An A. Your grade will be an A if you do your homework. Suppose I said this. At the end of the semester, you got your grade. The question is, when do you get angry? At the end of the semester. You got your degree. You check that from online. So there are 4 situations, right? So just imagine these 4 situations and think about the situation that you get angry the most. When you get angry the most in these 4 situations. Let's look at this. So this is P, right? You do your homework is P, you get an A is Q. So this is basically this form. If P, then Q. So look at this. You did your homework, you got an A. Are you angry about this? This is okay. If it's okay, then it's true. You did your homework, but you didn't get an A. You will be very mad at me, right? You will say, I am a liar. So this is false, because you are very angry this time. What about this? You didn't your homework, but you still got an A. Are you angry? Would you be angry at me? No, you will be okay. You will not call me a liar. This is fine. It's so far fine. So you didn't get your homework. You didn't get an A. You may get angry at yourself, but not at me. You cannot call me, I'm a liar, right? You didn't your homework because you didn't your homework. So what I said is going to be true unless this happens. Only at this situation, what I said would be wrong or false. Other than this, these 3 other situations, this will be true. This is why, and it is natural in our intuition, because this is only time you will call me a liar. This is very important to understand because this is very simple, but I've seen many students who got confused about this. So remember, if P is false, it will be true whatever the value of Q is. It's always going to be true if P is false. So this is very important, but still many students got confused. So let me emphasize one more time. This is true whenever P is false. Whenever P is false, it will be true. This is called, said to be true by default. Or it's called vacuously true. You don't have to it is like the principle of being innocent. I don't know. 무죄 추정의 원칙 in Korean. Just imagine, I don't know the correct way to say this, but in English, but basically it means you have to assume that the suspect is innocent unless you have proof. In Korean, yeah, it's called 무죄 추정의 원칙. So it will be always true unless you have a proof of this, proof of that is not true. if there's nothing to check, then it will be always true. Remember that. Any question about this? So for instance, if I said, suppose I said this, if you do your homework, then you will get an A. And just suppose that there was no homework at all. Then what I said, is it true what I said or not? I said this, and there was no homework. And is my sentence true or false? It's true, because there was no homework. Vacuously true. Yeah, so it will be false only if we have a student who did homework but did not get an A. That's the only situation when this is false. Other than that, if there's no homework, of course it's true, because it's not in this case. Remember that. All right, so let's see some examples. Suppose that P is a proposition which is true, and Q is false, R is true. Let's see what these are. The truth value of this. Second, not R. So let's determine their truth values. Okay, what is this? What is the truth value of this? P and Q, true and false. That will be false. So the assumption was false. That means you don't even have to look at this. It's going to be true, because this is false. It doesn't depend on R, the truth value of R, because it is already false over here. What about this? True or false? True and true or false? False. The true, if true, then false. So it will be false. And yeah, we need to determine this first. What is the truth value of this? True, because if F, then something is always be true. So it's true, true, so it's true. What about this? We need to determine this first. This is true, because the assumption was false. So true, then true, so it's true. You can determine the truth value by computing this proposition inside a bracket first. Okay? All right, and when we have a conditional proposition, we can talk about the converse. Converse of if P then Q is the statement or proposition. If Q, then P. You just switch the order of P and Q. This is called the converse. Converse. So, example. The converse of the statement, say, if x equals 2, then x squared equals 4. Is what? You just switch these two. If x squared equals 4, then x equals 2. The converse of a proposition, the truth value of the converse may be different from the original conditional proposition. Note. P, or if P, this and this may have different truth value. For instance, this. Is this true? If x equals x squared, x equals 2, then x squared equals 4. This is true. But this x squared equals 4, then x equals 2, it's not true in general, if x is a real number. Yeah. So this is true, but this is false in general. So they are different. Sometimes they can be the same, but they can be different. Sometimes. All right? Is it okay? Any question about this? Oh yeah, I expected that question. Thank you for asking that. So the question was, is this a proposition? Is this a proposition? So if you remember last week I talked about something like this. This is not a proposition, I said, because it's not, we cannot decide whether this is true or not. It depends on x. So in that sense, you're right. This is not a proposition. So we have to say what x is. So we will talk about this later today. Yeah. This kind of thing is called a propositional function. It is a proposition when x is decided. So we will talk about this in more details later. Yeah. So maybe this may not be a good example right now, but yeah, it will be clear. Hopefully 1 hour later. Other questions? So another definition. So we can also construct a proposition this way: P if and only if Q is denoted by this. We have now both arrows, both to the left and to the right. This means P if and only if Q. And this is defined as follows. Truth value is defined like this. There are 4 situations: TT, TF, FT, FF. This is defined to be true, false, false, true. So you can see this is true if their truth values are the same. You can think about that way. Think of this that way. If their truth values are different, then they are different. It is false. Otherwise, true. This is also sometimes in many math books or lectures. Sometimes it's also written as follows: P if and only if IFF. This should be understood as this. This is a shorthand for this. P if and only if Q. So 1 less than or equal to 5 if and only if 2 less than or equal to 8. Is this true or false? True? Why? Right. This is true. Right? 1 is less than 5. This is true. 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 Yeah, true. If and only if true, this is correct. This is, true. True. Yeah. Of course, this looks very strange. No one will use this kind of stuff, but it is true. True state, true proposition in this definition. All right, now I'm going to define equivalence of 2 propositions. Suppose that we have 2 propositions, but we have seen that using propositions, by combining propositions, several propositions, we can make a new proposition, right? So suppose you have 3 propositions, and then you can, by using this AND operation or operation, or if A then B, something like that, you can make a new proposition. There are many, many different ways. Suppose that P and Q are propositions constructed that way. Propositions made of propositions P1, P2. So just imagine that these are in some sense simple propositions, and these are more complex propositions made of this. Something like P1, P2 implies P3, something like that. You can make many, many propositions out of this. We say that P and Q are equivalent, or just logically equivalent, if the following holds. So these propositions, they may have different truth value. P1 may be true or false. There are many possibilities. There are, in fact, 2 to the n possibilities. 2 possibilities for each proposition. For all of them, for any truth truth values of P1 Pn, we have either P and Q are both true or both false. So in any possibilities of these, P and Q have the same, exactly the same truth value. It can be true or it can be false, depending on the values of these, but they have to be coincide. Maybe some example will be helpful. This is called the Morgan's law. We will see an equivalent, 2 equivalent propositions. Not P or Q is equivalent to, oh, I didn't write this. This is denoted by this. P congruent to Q. We use 3 bars like this, horizontal bars. It means P and Q are equivalent. This is not P and not Q. This is a proposition made of 2 propositions, right? P and Q. This is another proposition made of 2 propositions. They look a little different, but they are equivalent in the sense that if you decide the truth value of P, truth value of Q in any way you want, they will be the same. They will be the same. So how can we show this? Suppose you want to show this. There is always a very simple way to show a proposition like this by considering all possibilities using truth value. Proof. Let's prove this. Consider all possibilities for P and Q. There are only 4 cases, fortunately. And you compute this and this separately and see if they are the same. So make this table, this truth table. So we have 4 possibilities: true, 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 false, false, true, false, false. There are only 4 possibilities. So if P is true, Q is true, what is this? This is true, and we have negation, so it's going to be false. And here, what is not P? False. False and false is false. Look at this. P is true. Q is false. So what is the value of this? True. So negation, so it's going to be false. This is what? False. False and true. False and true is false. Right? And here is false, true. So this will be true. Not true is false. True and false is false. And false and false. This will be true, not true. False, so not false will be true. True and true is true. Now we have 4 rows, but they are always the same. F, 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 F. So they are equivalent. So this is a proof of this. This is a proof. Very easy. All you need to do is to list all possibilities of the truth values for the propositions inside this. All right? Easy? Another one is you can prove this similarly. This is also true. These two are equivalent, and this can be showed in the exactly same way. You compute this and this for each choice of P and Q. Can you do that? I mean, can you do that? No, the same. Question? All right. Okay. Let's see another example. This is equivalent to not P or Q. Do you think this is true? Just before, of course, we can prove this by making this truth table. That's very straightforward. But before doing that, just check your intuition. Do you think this is true? If P, then Q. Is this equivalent to not P or Q? Do you think they are equivalent? Yeah, they are equivalent. Yes. Because if P then Q, that means if P then Q. So either QP is false or Q is true. How can I say more than that? I just repeated this. But if you want, we can prove this using truth table. List 4. Yeah. But do you think this is natural? Your intuition tells you that this is true? So for instance, suppose I said, just use the previous sentence that I used. If you do your homework, you will get an A. Is this equivalent to this? Either you don't do your homework or you will get an A. They are the same. You don't do your homework or you'll get an A. Yeah, they are logically equivalent. If you don't believe me, write the truth table. Because this is false only when is this false? This is false if both are false, because it's or. It's false if and only if this is false and false. That means P is true and false. So this is exactly the same as this. Think about that. And P, we wrote this, P if and only if. This is P. This means if P then Q and if Q then P. This is equivalent to this. So basically it means two things. P then Q, if Q, if P then Q, if Q then P. Yeah. They are the same. You can prove this using truth table. All right. Another definition. The contrapositive of this statement or proposition is this: not Q, then not P. So in Korean, you will probably learn this as a 대우, contrapositive. And you probably remember this fact. A conditional proposition is equivalent to its contrapositive. If P then Q is equivalent to its contrapositive. Proof by truth table. Yeah, just make the truth table. So in words, this says every conditional proposition is equivalent to its contrapositive. So this is very useful fact. Positive. Because sometimes contrapositive is easier to prove than the original proposition. But if you know that they are equivalent, you can just choose the original form or its contrapositive. So it's a very nice, simple but very nice and useful fact. Any question? All right. All right, now I'm gonna give you some problems. True or false, that's the problem. Decide they are truth, false. 1. I'm gonna just give you a few minutes to do this. Decide whether each of these is true or false. This one's kind of complicated. I think I need one more. I'm going to give you 5 minutes to solve these problems. Okay? Think about this. You may talk to people sitting near you. You can discuss. I'm going to give you 5 minutes to solve this Some of them will be quite simple. Some of them you need to think about it. 이거요? P or P or R. Yeah, this pen is not very good. It's not my fault. It's my excuse. They are all alphabets are propositions. That is my answer. 5번, 6번. 응? 아. Yeah, then it'll be easier. Yeah, they are really the same. Okay. Be careful not to write T and F, something like that. If you want to get a perfect score, of course. If you want just, at least we want to get one correct answer, you can do that. Okay, I'm going to do, have you done everything? Do you need more time? Okay, a little more time then. Oh yeah, let's remove this. Five problems. These are, 이것도 같구나. Oh, that's what you said. Two of these. Okay. Now we are down to only 4 problems. It's good. Okay, I think for 4 problems we have enough time. So I'm going to do this. We will vote for each problem, and I'm going to write down the correct, the truth value. More students voted. Okay, raise your hand if you think the first one is true. True. Or can you raise your hand higher? Okay, only a few. And false. More people think it's false. Okay. Second, true. True for the second. All right. Or let's do one more time. True for this sentence. All right. And false. Okay, I think there are more people voted for true. Really? 3, true. Okay, not okay, false. Okay, so most of you think these are false. 4, true. 4, true. False. 4, false. But not many. Okay, let's see. But not many. Is this false? Really? I thought it was true, but I could be wrong. Let's see. 1. Why is this false, if you think this is false? P equals F. R equals T. Then, what about Q? Doesn't matter? Okay, let's see. P, F, and true. So it's going to be F. Right-hand side, what is this? Oh, I see. I'm a little confused. Okay, this is what? False, because this is false. This is true, because this is true. So, yeah, it is false. Why I thought this is true? Or false. I mean, true. Okay, this is false. I was wrong. Oh, I see. Yeah. This should be. I want this to be this, but no. Because this is kind of a theorem. But yeah, at this form, it is false. Yeah, you're right. Yeah, I want this to be this, but anyway. Second, true. Is this really true? Because my answer is different. All right, true. How did you prove this? Oh, TFT will be a counterexample. TFT. So P equals T. Let's consider this. So P, Q, R are like this. What is this? Is this true? False. So the left-hand side will be false. Right-hand side, what is right-hand side? True and true. So it's true. So it's false. So it is false. It should be false. 3. False. If you think this is false, then you have an example like this. Can you tell me the example of this? For examples of the truth values for which this is false. T, F, F. Okay, TFF, this will be false, right? So this will be true because it's false. T, F, F. False, false, so it's true. True, true, so it's true. So it's false, yeah, it's correct. Because in this case, they are not the same. This is false, it is true, but this proposition is false. The answer is correct. But how did you prove this? One way, of course, is to list all possible truth values of this. There are 5 propositions. So you have to look at 2 to the 5th, which is 32. You have to write 32 possibilities of T's and F's. And if you check that every time it is they have the same values, then you can conclude that they are the same. I mean equivalent. Otherwise, they cannot be equivalent. So if you said this is false, did you find an example of these truth values for which these are different? Yeah, of course it is possible because this is false, but there is a better way to do that. Question? FF. true요? 이거 잘못됐어요? Okay, so FFF will be the correct answer. Yeah, sorry about that. I don't know. This is false anyway. Other question? All right, so let me talk a little bit about this number 4. The idea is the following. You can notice that t is only here. T is not in the left-hand side, right? So if you change your values t, suppose that p is true. Suppose that p is true. Then this t can be either true or false, right? If t is true, this will be true. If t is false, this will be false. But on this side, there is no t. So suppose that p is true and RS are decided anyway. Doesn't matter. It will be fixed, right? But by changing the values of t, this will be changed. This cannot be the same because this is the same, independent of the value of t, but it depends on t. Something depends on t, the other one does not depend on t. How can they be the same? Oh yeah, you're right. If p equals f, you're right. If p equals f, this is true if and only if t is true, but there's no t. So if you really want an explicit example, you can just say, okay, p, f, r. You can give any truth value, doesn't matter. S equals, say, t, q equals t, doesn't matter, and t. Okay, I think I need more space. Okay, I want this to be in one line. So suppose that I made, let me erase this part. Suppose we have truth table. Suppose we want to create truth table, P, Q, R, S, T. What I said is, this is left-hand side, right-hand side. Let's say we want this to be false. False, false. Just say anything, T, 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 T. And let's say this is true or false. Here, you can compute this, but it doesn't matter. Let's say this is A. A is either T or false. What is this then? It will be A. They have to be the same because the left-hand side depends only on this, right? They are the same. Must be the same. You don't need the value of that. It doesn't matter. But here, what is this? T, F, T, this T is false. So at least one of these will be different. So it cannot be the same. You don't have to decide this truth value. So this will give you, one of these will give you an example when these two sides are different. So this is one way to show this.